This video is on real numbers from Exemplar. In this video, I have explained 5 sums from exercise 1.1 and this is my part 1. Now I'm going to start exercise 1.1. Choose the correct answer from the given 4 options in the following questions. So I'm going to write 2 questions, question number 1 and question number 2 here. Now the 2 questions are, for some integer m, every even integer is of the form. There are 4 options: m, m plus 1, 2m, and 2m plus 1. And the second question is, for some integer m, every odd integer is of the form. There are 4 options: m, m plus 1, 2m, and 2m plus 1. You have to find the right one. I'm going to discuss answers of these 2 sums. Here I am going to write Euclid division lemma. Given 2 positive integers a and b, here b is equal to 2. There exist integers q and r such that a is equal to 2q plus r, where r lies between 0 and 2. Here values of r is 0 and 1. Because r lies between 0 and 2, so value of r will be 0 and 1. If r is 0, a is equal to 2q. If r is 1, a is equal to 2q plus 1. Now here I am going to explain what are even numbers and what are odd numbers. Now even numbers, when we divide a number by 2, if remainder is 0, then it is an even number. If a number a is divided by 2 and if remainder is 0, then it is even number. And what are odd numbers? If a number a is divided by 2, if remainder is 1, then it is an odd number. Again, come to this point. Here remainder is 0. If remainder is 0, this is an even number. And if it is an even number, this is of the form 2q. Here remainder is 1. So this is an odd number. So this is of the form 2q plus 1. So it means for the first question, for some integer m, every even integer is of the form 2m. And for some integer m, every odd integer is of the form 2m plus 1. Generally, we write q for quotient. But here I can write, for this question, I can write here m. If I take this as m, it will be 2m plus r. It will be 2m and it will be 2m plus 1. Now the question number 3. Now the question is, n square minus 1 is divisible by 8. If n is an integer, a natural number, an odd integer, an even integer, value of n should be what? Whether it is an integer, whether it should be natural number, whether it should be an odd integer, or whether it should be an even integer. N square minus 1 is divisible by 8. This is given to us. Now, let this number is 8. Let me substitute n as 0, as 1, as 2, as 3, as 4, as 5. If n is 0, then a is equal to minus 1. If n is 1, a is equal to 1 square minus 1, that means 1 minus 1, that is equal to 0. If n is 2, then a is equal to 2 square minus 1 is equal to 4 minus 1, that is equal to 3. If n is equal to 3, a is equal to 8. If n is 4, a is equal to 4 square minus 1, that is 15. If n is equal to 5, then a is equal to, that is 24. Let me take 2 more examples, any numbers. If n is 14, then a is equal to 195. If n is equal to 15, then a is equal to this 224. Now what we have seen, if n is 0, a is minus 1, is this divisible by 8? No, this is not divisible by 8. N is 1, is this divisible by 8? Yes, 0 divided by 8 is 0. So this is divisible by 8. N is 2, is this divisible by 8? No. If n is 3, is this divisible by 8? Yes. If n is 4, is this divisible by 8? No. If n is 5, is this divisible by 8? Yes. If n is 14, is this divisible by 8? No. If n is 15, is this divisible by 8? Yes. It means when n is 1, it is divisible by 8. When n is 3, it is divisible by 8. When n is 5, it is divisible by 8. When n is 15, it is divisible by 8. It means odd numbers. You just see odd numbers, odd integers. When n is an odd integer, then it is divisible by 8. So according to this statement, C is the answer. C is the answer when it is divisible by 8. So this is a multiple choice question. Sometimes you can substitute the values and you can see what is the answer. Now there is one more method of doing it. We know odd integer can be written in the form of 4q plus 1 and 4q plus 3. Any odd positive integer can be written in the form of 4q plus 1 and 4q plus 1. If we take this as n as this number or n as this number, so they are odd integers, and then n square minus 1 will be divisible by 8. We can check it like this. So on the next page, we are going to check for odd integers whether n square minus 1 is divisible by 8. Let us check it. Any positive odd integer can be written in the form of 4q plus 1 and 4q plus 3. So if n is an odd integer, 4q plus 1, then we are going to check whether n square minus 1 is divisible by 8. Let us check it. 4q plus 1 whole square minus 1. That is 4q whole square plus 2 into 4q plus 1 minus 1. This is cancelled. I have 16q square plus 8q. Take 8 common. 2q square plus q. That is 8m, where m is an integer. It implies n square minus 1 is divisible by 8. It means n square minus 1 is divisible by 8 if n is an odd integer. Now, let me check it for 4q plus 3. If n is equal to 4q plus 3, then n square minus 1 is 4q plus 3 whole square minus 1. It means 4q whole square plus 2 into 4q into 3 plus 3 whole square minus 1. This is 16q square, 24q plus 9 minus 1. This is 16q square plus 24q plus 8. Take 8 common, 2q square plus 3q plus 1. This is 8m, where m is 2q square plus 3q plus 1. It means n square minus 1 is divisible by n square minus 1 is divisible by 8 if n is odd integer. So C is the right answer. Now the fourth question is, if the HCF of 65 and 117 is expressible in the form 65m minus 117, then the value of m is, there are 4 options, 4, 2, 1 and 3. So I am to find the right one. Now HCF of 65 and 117 is expressible in the form of 65m minus 117. It means HCF of 65 and 117 is equal to 65m minus 117. Now I am going to find HCF of 65 and 117. I'm going to apply Euclid division algorithm. And if I divide 117 by 65, so I'll get 117 is equal to 65 into 1 plus 52. So if you can't do it mentally, you can take the help of this division. 117 divide by 65, 2 and 52. 52 is the remainder. Now 65 is the dividend, 52 is the divisor, and into 1 plus 13. Again, if you find it difficult, you can do it like this. 13 is the remainder. Now 52 is the dividend, 13 is the divisor, into 4 plus 0. Now it's easy to calculate, but again, if you find it a problem, if you find it difficult, you can do it like this. 0 is the remainder. Now it means HCF of 65 and 117 is equal to 13. This is the HCF. It means HCF of these two numbers is 13. I'm going to write this line again. So this is equal to 13. We have just calculated it here. So HCF of 65 and 117 is 13. This is equal to 65m minus 117. 13 plus 117 is equal to 65m. It means 130 is equal to 65m. It means 130 upon 65 is equal to m. 65 to the 130. It means value of m is equal to 2. So B is the answer. Now the fifth question is the largest number which divides 70 and 125, leaving remainder 5 and 8 respectively. There are 4 options. First option is 13, B is 65, C is 875, and D is 1750. You have to find the right one. You are to find the largest number which divides 70 and 125, and that leaves the remainder 5 and 8 respectively. For that, I am to find a number which divides 70, you will get remainder 5, which divides 125, you get remainder 8. For that, first I will subtract 5 from 70 and 8 from 125. Then I'll find the HCF of that number. So I am going to subtract 5 from 70. 70 minus 5 is 65. And 125 minus 8 is 170. Now I'm going to find HCF of 65 and 170. In the previous sum, I found the HCF of 65 and 117, that is 13. I'll do it again here by Euclid division algorithm. If I divide 117 by 65, I'll get one quotient and one remainder. So 117, it can be written as 65 into 1 plus 52. Now 65 is a dividend and 52 is a divisor. Again, I'll get 1 as quotient and 13 as remainder. Now 52 is the dividend, 13 is the divisor, 13 fours are 52 and 0 is the remainder. So 13 is the HCF. So HCF of 65 and 117 is equal to 13. Now 13 is the number which when divide 70, you will get 5 as a remainder, which divide 125, you will get 8 as remainder. I'll check here. If you divide 70 by 13, 13 5s are 65. You will get 5 as a remainder. If you divide 125 by 13, 13 9s are 117, you will get 8 as a remainder. It means if I subtract 5 from 70 and 8 from 125, and if you find HCF of these two numbers, you will get the result. So here answer is 13, and so A is the right answer. So in this video, I have explained 5 sums. So next 5 sums, I'm going to explain in the next video.